is 60. That's one of them. You always give me the second one. What's the other? Yeah, Jennifer. They're both 60. Why are they both equal 60, class? Yeah, we're going to. It's a round trip, right? They tell us that they're both. You know, of course, if you go downstream 60, you have to come up 60 kilometers, right? Pecco, question?
Is there going to be like problems where the distance is different?
Yeah, so we're gonna get to those. Very good question. But then if the distance is different, guess what? Yeah, so you will have those. Don't worry about it. Okay, so first of all, do you think I should just distribute the 3 and 5? No, why not? Yeah, look, does 3 go into 60? Does 5 go into 60?
Yes.
The 3 and 5s are GCF of those, right? They're factors of those left side of the equation, right? Those expressions. So do you think you should simplify first? Yeah, what do I get if I simplify? Claire, tell me what I get if I simplify the first equation. Correct. And what about the other one? Good. And do you think we could use, what method would you use to solve this? Yeah. Addition method. So go ahead and write it down vertically. Go ahead. I'll give you some time to finish. Have you soon. Good. So, by the way, does it make sense, guys? Let me ask you this. Does it make sense that the rate, look at the rate. Which rate is faster? R plus W or R minus W? It's faster, and does it make sense that the time is then shorter to go to the same distance, right? If you're going slower, it'll take you longer time, right? So check your work that way. Sometimes they plug in the wrong time, okay, and get the wrong answer, right? So when I add them together, I get 2R. Did you all put down 2R? Don't put R. R plus R is 2R, right? Equals to 32. R equals to, how many people got 16 kilometers per hour? Very good, very good. Okay. Now, if the rate, what does this represent? 16 kilometers per hour. Is this the current or is this the boat? Yeah. It's the rate of the boat in still water, meaning if there was any current, right? If you're on a swimming pool or something like that, okay? If you're, so then there it is. Now, what is then? Do they ask for the rate of the current also? Oh, they don't? No, they don't. So you don't have to actually. I mean, if they ask you, you can figure. What is it, by the way? If you want 4, because look, right? R plus W must be 20, and R minus W must be 12, so you get 4. But you know, they didn't ask for it this time. That's okay. All right. So that's all you write. Okay. So this time, it's very short. You just write down that the speed of the boat in still water. That's important, right? To indicate that it's still water. It is 16 kilometers per hour. Yes, Danielle?
What if on a test the speed of the boat would be 16 kilometers an hour?
So you have to mention somewhere that still, because since they're asking the, yeah, don't do that. Then, yeah, you will. Okay, so let's look at example 3. Who would like to read for us example 3? Go ahead, Tina.
Sally is planning a 3-hour trip down the river and back to a certain point. She knows that she can paddle in still water at 3 miles per hour and that the rate of the current is 2 miles per hour. How much time can she spend doing this? Going downstream? How far downstream can she travel?
That's correct. So now it's a little bit different than the first two. How is it different than the first two? So right away, something's different, right? What's different? Dieter? How about Scott?
I don't know.
How about Pecco?
I have a question.
Okay.
The first sentence where it says it's a 3-hour trip, is it 3 hours down or is it down?
Okay, who can answer that? That's a good question. When they say 3-hour trip down the river and back, does it mean only down 3 hours? No, it means the whole trip. Okay, so that's right. So who can tell me then how is this different than the other one? Why is this different, first of all? Okay, Berge?
Because it doesn't give you, first of all, it gives you the rate
For?
for the current and the how fast she goes in the still water.
Right, so it's the unknown is going to be different, isn't that right?
Yeah.
So what is it that we are looking for? Kevin? The distance of the? It's time. So somebody says time and the distance. Okay, so let's look at this. First of all, one of the things that we have to look at is at the very end. It says how far down the stream can she travel? Now, so let what? D equals to the I did the d for the time it'll take for it to go downstream. Okay, isn't this one of the variable, the time? Aren't they asking for the time? They're asking two things, right? How much time can she spend going downstream? Correct? You want to do t? That's fine. I did d for downstream. Yeah, but yeah, you're right. You could do t if you want. I just did d for downstream. Then what? What else do we know? If the t is how long it takes her to go downstream, because that's one of the questions they're asking. Later they ask you for how far. But right now, d is the time it would take her to go downstream. Then how long would it take her to go upstream? How would you figure this out? Because we don't know that either, don't we? Is that right? What is the time then it would take her to go upstream? Now let's think about this. If it took her, what? How long did it take her to do the whole thing? Okay, now if d is the time it takes to go to yeah. It'll be 3 minus t. Then, you guys remember? By logic, right? If the whole trip took 3 hours, right? Wouldn't it take 3 minus d hours for her to go upstream? Okay. Any question? Are we good so far? Okay, write this down. That's a really good one. They didn't even ask for how long it takes her to go upstream, right? Why am I doing 3 minus d there? Anybody see why I did that? Because some of you say, well, it doesn't. They don't even ask for how long it takes you to go upstream. Why would you need to even represent that? Yes. Yeah, when you're doing a chart, you're gonna need the time for going what? Upstream as well. Don't you agree? So what is the rate for going downstream, guys? Yes, Brian?
5 miles per hour.
That's right. How'd you get that from? Where did you get that from?
Because in still water it's 3 miles per hour.
Okay.
And the current's helping it at 2 miles per hour.
Exactly. Very good. So the downstream is really 3 plus 2 is the boat and still water plus the current. Then who could tell me the rate for downstream? It is? Yes. 1. How'd you get 1? 3 minus 1. Would you not agree, guys? Isn't that the rate? 2? Yeah, I didn't declare any z, so it's 2. What about time? What about the downstream time? Do we know how long it takes her to go downstream? No. So guess what we put in there? D. Now, Tina, what about for time for upstream? Yeah, do you think we need 3 minus t? Yeah, we need that, okay? So, because we know we have to fill out this chart to get the equations. Does that make sense, guys? So then, what about the distance for downstream? What would we write the distance for downstream? Yeah, you basically multiply the rate times time, right? Which is what, guys? 5d. Is that right, 5d? Now, what about the upstream time? 1 times 3 minus d, which is us 3 minus d. You're right. Now, we have, how many variables do we have? Look at this equation. We have only one variable. How many equations do we need then? If we have one variable, how many equations do you need? 1. Okay, now, who can then tell me the equation that we would need to solve this? Okay? Kate. 5d equals to 3 minus d. Where did you get that from, Kate? Yeah, it's a round trip, guys. What do you know about round trip? Yeah, you have the same distance. Okay, so you're correct. The distance going downstream is same as distance going upstream, correct? Look, if I'm going A to B, right, it'll take same amount of distance to go up and, right? So you equate those together, the distances. Now, do we know how to solve this simple equation?
So
Okay,
simple.
what do we do? Caleb?
You add d, then you get 6d equals 3, then you divide by 6, and you get d equals to 1/2.
Which is in half an hour or 30 minutes. Now, what does that represent? D equals to half. What have we found, guys? Okay, raise your hand. What have we found? Getty? Yeah, it takes, that's the time it takes her to go downstreams, correct? Now, is that all they ask? Okay, so we found, that's one of the part, right? Look at how much time can she spend going downstream, which means she could spend 30 minutes, right? Now, what happens if she spends more than 30 minutes? Yeah, she cannot come back within 3 hours. Does that make sense? It'll take a lot longer. So first,